Hi friends, we're in Unit 4, Day 2. Now let's graph exponential functions using transformations. So the transformations, again, the transformation toolbox, we talked about what happens, again, when you have a negative value here. So our base is 3. When we have a negative value here, we're going to reflect. In this case, we're going to reflect across the x-axis. All of our resulting values are going to be negative. So like, if we think about our original, with base 3. If I have my x comma y, what's happening? Well, in this case, I still have that negative 1, 0, and 1. This is going to be 1/3. 0 gives me 1, 1 gives me 3. So now what's happening with that negative is that I'm going to take my resulting y value. So with that transformation, we're going to take that y value, and we're going to take that resulting y value times a negative 1. So now we're going to end up at opposite y. So if I have negative 1, 0, and 1, I end up with negative 1/3, negative 1, negative 3. So these values here are now here instead. So this is an exponential growth that's reflected across. So this is kind of weird to think about it. It's an exponential growth, but it's reflected across the x-axis. This is an example of a type of function that you don't necessarily see a lot of use in real world because it's in the quadrant 3 and 4. Most often when you see exponential functions, you don't see them used in quadrant 3 and 4 because of how we just described it. I said this is an exponential growth reflected. Clearly you can look at it and see it's an exponential decay. It goes down, it decreases as you move from left to right. And so as we continue on with this, we're going to see that, in this example here, this is pretty impractical. But then again, that's a transformation. Oh, domain and range. So our domain and range is slightly altered. Domain is not. Range is, though. Our range is now from negative infinity to 0, non-inclusive, for 4. So now we have a sort of transformation here, and we're -2. So this actually is awesome because we have a few different types of transformations that's happening. So for the first transformation, what we have is our original. So again, original with base 3. So that's my x and y, negative 1, 0, and 1. So 1/3, 1, and 3. Now my x value, this is adding 1 to each of these values. So now if I do x plus 1, for my resulting y value, at the end I need to subtract 2. So my x plus 1, and then my y is going to be whatever my resulting y value is minus 2. So here, my x plus 1, so my negative 1 plus 1, I'll go ahead and put that on here. 0 plus 1, and then 1 plus 1. And then for my y minus 2, that's 1/3 minus 2, 1 minus 2, and then 3 minus 2. So then my resulting final plots to point here. So I have 0, 1, and 2, and then 1/3 minus 2. So let's see, that's minus 6/3, so that's negative 5/3. Or negative, let's see, that's negative 1.6 repeating. It's easier for me to graph decimals. Negative 1 for this, and then, let's see, that would be 1. So if I graph these values, 0, and then negative 1.6, it's going to be here. 1, negative 1 is here. And then 2, 1 is here. There we go. And then I know my asymptote here is going to be at that negative 2. So again, showing it to you with this blue, so you can see this is adjusted. So what was I using? Green. So we had a little Nice little vertical shift going on here. It went down for real, using song references that date myself. I'm an old man. My domain is all real numbers. And then my range, here, I go from -2 to infinity. In the real world, we actually see exponential functions a lot, except they use a particular type of value. They use the natural exponential function. So we use e. Our approximation for e is 2.7. If you were in, I know Edwards does this. A few other teachers also go through and derive this. You get closer and closer to that value. If I want you to evaluate e, then just use 2.7. In your calculator, just so that you know where e is, that's where this evaluating exercise down here comes from. E is in most of your calculators. It's not the capital E on your graphing calculator. It's actually right here with the 2, or sorry, with the divided by. But to get it, you have to do the second key and then divided by, and then you get E. Just kidding. It's the natural, my goodness, what a day. That's not the right E, that's a different E. Second natural log down here, e to the x is the one that we're looking for this. You should get a parentheses if you're using an older version of the TI. If you're using this version of TI, then you should get e, and then it gives you that floating box to show you that you're plugging in the values. So e to the first gives us what we had from up above, that 2.71. And then you can continue on, find e to the 0. So e to the first is approximately equal to 2.7. E to the 0, I don't use my calculator for. That's exactly 1. Anything to the 0 power than 0 is 1. And then e to the 1/2 is approximately equal to 1.6. All right. Join me in the next video as we talk about solving exponential equations. Have a good day.